So let's talk about arithmetic sequences. Who knows what an arithmetic sequence is?
I don't know what it is.
I'll tell you what it is. Okay? 5, 8, I don't know why I keep using the same one. Okay? This is an arithmetic sequence because if I take the difference, any two terms, basically between any two terms, it's just how much? Get from the first term to the second term, what do we do? Plus 3. Second term to the third term, we do?
Plus 3.
Okay? And it keeps going on. Between any two terms, you can think of it the other way. 8 minus 5 is 3. 11 minus 8 is 3. Keep going here. What's the next term of the sequence?
17.
17. Good. Okay? So A1 equals 5. Okay? That's just the first term of the sequence. That's how we read A1, the first term. A2 equals 5 plus, how many 3's do I add?
1.
Just 1. So it's 2 minus 1. This 2 goes to here, and we add 1 less 3. Because to get to the second term, we've only added 1 3. Someone was talking about this. We did a problem about raises. This is like the second year you work somewhere, you've only gotten 1 raise. Let's say every year you babysit, you get $3 more each year. Something crazy like that. The second year, you don't get 2 raises, you only get 1. A3 equals 5 plus how many 3's?
2.
1 less than 3. No, you got it right. It's 1 less than 3. How about A10? 5 plus how many 3's?
10 minus 1.
So AN would equal
10 minus
3's. Okay? In general, we could generalize this to AN equals first term plus, well, we're not there yet, n minus 1 times, we use D to represent that constant. Yeah.
Wait, the 3 is a constant.
The 3 is a constant, yes. D is, we could pick for any sequence. We could pick a sequence where you go up by 5 each time. Pick a sequence where you go up by 2.5 each time. Doesn't matter, it could be anything. This is the general form for the nth term of a sequence. What were you going to ask?
Wasn't that the constant also called like the ratio or something like that?
The ratio comes in the geometric, we'll get there.
Okay.
But it's the common difference is what they mean. Okay? What about for the sum of a sequence? How did Gauss do it? He didn't go 1, 2, 3, all the way down to 100. He did the first term plus the last term.
50 plus 51.
And then how many of these were there?
50.
So it was 101 by 50. So it was 101
Times 50.
this way times 50. It was, I'm going to do it this way. It was 50 times 101. Okay? I'm going to write it this way. It's 100 over 2, right? That's how we knew how many rows we had, right? If we're adding up to 200, there would be 100. If we're adding up to 1,000, there would be 500. It's 100 over 2 times the first term plus the last term.
So this is the arithmetic.
This is still arithmetic, yes. So this is saying the sum from, let's use k. K equals 1 to 100. Let's review sigma real quick. How do we read this? We say the sum of this sequence. And this sequence says, okay, when I put in 1, I'm adding 1. Then I put in 2 plus 3. It's just the sum of k. Okay? From k equals 1 all the way up to 100. That's the same way as saying add up all the integers from 1 to 100. And it equals this thing. In general, for an arithmetic sequence, this even generalizes for, doesn't matter if you start at 1 technically. So for any arithmetic sequence, it says add up all the terms in the sequence. That's all that says. We don't know what the sequence is. It equals the number of terms over 2 times the first term plus the last term. using, yep, that's good. There's my one problem there.
Now, do you use, so we just have two formulas, right? Can you use any one when you're doing arithmetic, or do you have to use a certain one?
So there's a difference. Who can answer that question? What's the difference between this and this?
Bonus multiplication. Oh, that's
The one you're adding the first and last term.
They give you different things. This gives you the general term. This gives you the nth term. It says if I want the 50th term, I turn to this formula. If I want the 100th term, I turn to that formula. This says if I want to add them all up, this is the formula I use. So totally, they're both for arithmetic sequences, but one says I want the 50th term. The other one says add them up from 1 to 50.
A to the n is the last term.
Yeah.
N is the last term. AN, this is the first term plus the last term. Because we're adding all the way up to, here it would be the first term plus the 100th term.
So for the general form, if you wanted the 50th term, it would be 51 minus 1, right?
If
I'm
you
just
wanted
giving
the-
an example.
This one is too simple, unfortunately.
I'm talking about the general term.
The general term
Yeah.
would be,
If you wanted the 50th term,
well, we have to find out. The first term is what?
it's 5, right?
A1 is, now what do we start with in this sequence?
1.
This is a little too simple for you to see it well. We start with 1 plus how many?
I'm trying to get the 50th, right? So
So you want the 50th term, it's 50 minus 1. And what's the difference? What happens between each of these terms?
1, 3. Oh,
Just 1. So does that give us a 50th term? It's 1 plus 49 times 1. That works. This sequence is very simple, is what's tripping us up. I picked a simple one, but it's a little too simple, it sounds like. Okay, but that's the basic idea that I hope is making sense now. That the reason these are different, this gives you the nth term, and this lets you add them all up. That's why they're different. You go?
Can you give us an example?
Sure. Why don't we do uh, 20 of, why don't I give you an easy one? Okay, let's say that A1 is 3. Add that on up. And I probably would have asked this a different way. I probably would have said, and made you figure it out yourself. What's the common difference? Well, do we even need to really know this? But yeah, get the common difference aside. What do we need? We just need to know we're going to use n over 2 times the first term plus the last term. So the real thing we need to know is the last term. So what's the 20th term? So you got to use both. How do you find the 20th term? 20th term would be, what's A1?
3.
First term is 3 plus how many 5s?
19.
Yep. So what's that?
Goodness.
97? 98? 98, yep. So it's 20 over 2 times 3 plus 98. Was that the question?
What was it that you figured it out?
98.
Oh, 98.
Yeah.
Okay.
So then we get
Why
what?
you took 20?
Wait, I have a question. So what happened to the 5? So we know 3 is our A1 in the first term, and the 5 is what? Is that the constant?
5 is the constant, yeah. This is this, let me write this up, this is this formula. Equals the first term plus, you got it, go on.
I just want to talk about with the Greek letter thingy, because you have 3 plus 5 times k minus 1. So in this one, is the 5 the constant?
Yes,
All right, got it.
there you go. You could have, it may have been even easier to read it off here than 5 was the constant,
Yeah,
right?
exactly. Okay.
Let's try and restart here.